Hi Srishant. Today also I came up with an audio project because it's still an interesting hobby making audio devices and circuits. You can get that satisfaction when you're listening to something made by yourself. You may buy this kind of stuff from eBay or AliExpress, but you can get more satisfaction if you can design it by yourself. So keep in touch. We can discuss about practical issues when implementing a circuit design. I will give you some tips. This is my YouTube channel, How It Sounds with Roshan. Don't forget to subscribe. Okay, today I'm going to design a simple microphone amplifier using an op-amp. Designing with op-amp is pretty easy. You can use simple mathematics. Back from O-level science book, you may remember this circuit. This is the inverting configuration of operational amplifier. And the transfer function Vout equals minus Vi into R2 by R1. The gain will be R2 by R1. Now we have two questions. What components to use? What values to use? First, when you're choosing an operation amplifier, there are so many with same pin configuration. You can use your favorite IC number, it will work, but there are a few types and facts you have to consider. For this kind of audio circuits, we can use general purpose operational amplifiers. Other types available are high input impedance type, low noise type, and wide frequency response type. You may consider about power supply you have and the package type if you have less space available. In this application, I used UPC4570 IC because the datasheet says low noise, wide band, high slew rate, an excellent choice for preamplifiers and active filters in audio instrumentation. Okay, second, we have to consider about the values of discrete components. When we consider in the circuit, the input impedance here of this circuit is equal to the R1 because the common voltage here is equal to the voltage connected to the non-inverting input, which is ground, you can see. I'm designing this circuit to use with a dynamic microphone. And my microphone is Behringer XM1800S. Input impedance according to datasheet 600 ohms. In this regard, the nearest value I have for the circuit is 619 ohms. Luckily I have some resistor values of E96 series, but not all of them, but in couple of years back I bought it from eBay. So then I want gain to be set 150 times. So R2 we can calculate like this. So R2 will be 92.8 kilo ohms. But in my collection I have 98.6 kilo ohms. Then actual gain will be 159.2 times. Still this is an incomplete circuit. More discrete components to be added to make it stable and noise free. Adding a capacitor in parallel with R2 improves the stability of this circuit. 160 pf. 160 pf is very useful value in audio circuits, so I kept 100 pieces package in my components collection. AC bypass capacitors for input and output direction, and the direction of the signal will be minus to plus. The output resistor helps to minimize stability issues. Also, it protects from excess power dissipation. If the output is accidentally shorted, also isolates capacitive loads. If a microphone is not connected, the input terminal is open, which can pick external noises. We can use an inbuilt switch in microphone connector to prevent this issue. I'll show you with my multimeter. It turns on if a mic is disconnected. It turns off if a mic is connected. We can use that switch to ground the input when the mic is not connected. Also a capacitor and a resistor to prevent making horrible noise if you connect or disconnect microphone while operating. For a smooth startup, I added another 2 resistors and capacitors to IC power supply. Place 104 capacitor much closer to the IC. Also remind to keep the physical distance between IC and R1 resistor as low as possible. You can check the audio quality of this circuit because I'm using it to record the whole audio track of this video.